So hello everyone. So here we will start with the other topics of the psychometry. So this is the part 2 of the psychometry. So the topics that we will discuss here are: the first is the Gibbs phase rule, the second is the sum formulae and their derivation, and the third is the numericals. So let's start with the Gibbs phase rule. So the Gibbs phase rule is not important for the GATE exam, but I will try to give you some idea that why some parameters or how many parameters are required to understand any thermodynamic system, right? So let's see it. So this Gibbs phase rule is given with this formula. So F equal to C minus P plus 2, where the F is the number of variables. These are the number of variables that are required to understand any thermodynamic system, and the C is the components, and P is the phase, number of phases, and 2 is the number. So for the psychometry, the C, or let's suppose this is a chamber or this is a room जहाँ पर moist air present है. So here the moist air is present. It means the components would be 2. So components would be 2. So how it is 2? One for the moist or the moisture or the water vapor, and the second for the dry air. So that's why C is taken as 2 and P is the phase. So because all the things are in the gaseous phase, so the P will be taken as 1. That's how we get F equal to C minus P plus 2, that is 2 minus 1 plus 2. It means total is 3. It means we need 3 variables to understand the system of any thermodynamic system from the psychometric point of view. ठीक है, जब हम साइकोमेट्री के न्यूमेरिकल सॉल्व करेंगे, सो व्हेन वी सॉल्व द साइकोमेट्री न्यूमेरिकल्स, वी नीड 3 पैरामीटर्स to solve the numerical. Okay, but all the psychometry problems happens at the atmospheric pressure. So the first is the pressure, the second is the temperature, the variable that we need to solve the numerical, and the third is the moisture. So here the pressure is always the atmospheric pressure. That's why we are finally left with only 2 variables. So if we have the temperature and the moisture content known, then we can very well solve the numerical. Okay, so the temperature can be the dry bulb temperature, or the wet bulb temperature, or the dew point temperature. And the moisture content can be given in the form of relative humidity or the specific humidity. Okay, so if we have any of these 2 variables, then we can solve any numerical. तो अभी आपको ये फॉर्मूला बिल्कुल भी याद नहीं रखना है. You need not to remember this formula or any of these things. Rather, you have to just understand that if we know any of the 2 things, then you can solve the numerical. Okay, so now we will start with the first concept, that is the specific humidity. So first we will look at the derivation, or the this definition of the specific humidity, and after that we will derive some formula for the specific humidity, then the relative humidity, and meanwhile we will also solve some numericals if possible, and then we will look enthalpy of the moist air, or the humid heat of the moist air. It means the energy contained in the moist air, and then the specific volume, because the question have come on this particular term. And after that, along with this, we will also look at some of the numericals. So I hope this lecture would be very interesting for you to watch. So let's see the first thing, that is the specific humidity. So the specific humidity is, it is represented with W, that is equal to the mass of water vapor divided by the mass of dry air. ये इस तरीके से समझो, सपोज यहाँ पर एक बॉक्स हमने दिया है जिसमें moist air present है, and suppose if this box contains the moist air or the room contains moist air, and let's suppose it weighs 1 किलोग्राम. सपोज इस पूरी एयर का जो moist air का जो वेट है 1 किलोग्राम है, और इसमें सपोज 100 ग्राम इज द वेट ऑफ द वाटर वेपर and the 900 gram is the weight for the dry air, then it would be equal to, or the specific humidity would be equal to the mass of water vapor, that is the 100 gram, divided by mass of dry air, that is the 900 gram. So it would be equal to 1 by 9. So you can calculate the things in the decimal form. Okay, so this is the specific humidity, and now let's look at the relative humidity. Relative humidity को भी एक बार देख लेते हैं. हालांकि मैंने कल आपको इसके बारे में काफ़ी डिटेल में बताया भी था रिलेटिव ह्यूमिडिटी के बारे में. सो रिलेटिव ह्यूमिडिटी is represented with this symbol, and it is written as the moisture in air divided by maximum moisture in air, or this can be written as, this particular denominator can be written as the water holding capacity of the air, or the water holding capacity of air. Okay, so let's suppose this particular chamber or the room is at certain temperature, and इस temperature पर इसकी जो maximum water holding capacity हो सकती है, let's suppose it is 200 ग्राम. ठीक है, 200 ग्राम तक हो सकती है. तो इस केस में जो रिलेटिव ह्यूमिडिटी होगी वो क्या होगी, जो अभी मॉइस्चर है वो कितना है एयर में 100 ग्राम. सो इट इज़ द 100 ग्राम डिवाइडेड बाय द मैक्सिमम मॉइस्चर दैट दिस एयर कैन होल्ड इज 200. it is equal to 1 by 2, that is the 50%. Okay, and one more thing, that maximum moisture holding capacity or the water holding capacity of the air, it is when the air is saturated. तो जब भी कोई एयर सैचुरेटेड होती है तब उसी केस में उसकी जो वाटर होल्डिंग कैपेसिटी होती है वो मैक्सिमम होती है. तो ये चीज़ आपको याद रखनी है. सो व्हेन आई से दैट द air can hold 200 gram of moisture when it is saturated, then it means that it is the 200 gram is the maximum water that this air can hold. So it is equal to 100 divided by 200, that is the 50% is the relative humidity. I hope ये आपको चीज़ें अभी समझ में आ गई होंगी. And the other thing is that how this relative humidity is related to the dry bulb temperature. So T dry, or the T dry bulb temperature, it is written as dBT. dBT, that is the dry bulb temperature. So if I increase the dry bulb temperature of the room or the chamber that we are talking or that we are considering here, so if I increase the temperature, then obviously the water holding capacity of the air will increase. ठीक है, अभी जब किसी भी रूम का जब टेम्परेचर बढ़ाया जाता है जिसको हम कंसिडर कर रहे हैं, तब क्या होगा कि जो उसकी वाटर होल्डिंग कैपेसिटी है वो इंक्रीज हो जाती है, जिस वजह से द डिनोमिनेटर विल इंक्रीज. इट मीन्स द रिलेटिव ह्यूमिडिटी विल कम डाउन. ओके, so if the dBT increases, then that would mean the water holding capacity of the air will increase, and that would mean the RH will come down. Okay, so these are there is a negative relation between the temperature and the relative humidity, but the specific humidity will not change because it is the constant things that is present here. So the mass of water vapor is constant and the mass of dry air is constant. It is not changing with the change in temperature, while the water holding capacity of the air will change with the temperature. So I hope you can easily understand these things, that the relative humidity will be affected by the change in temperature, but the specific humidity will not be affected by the change in temperature, right? And we can also represent this thing like this. So T dBT inversely proportional to RH, or the RH is inversely proportional to TBT TdBT. Okay, so this is the relation here, and और इस चीज को आप याद रखना. And now let's derive some formulas for the specific humidity and the relative humidity. For the formula derivation, or the derivation of the formulas, so first, for the specific humidity, so it is the mass of water vapor, that is mv, divided by the mass of the dry air, that is written as ma. And we also know the formula for the ideal gas, that is the m equal to pv by rt. So we can write it in this form. So mv, so pv into v is the total volume, and then rv into t is the temperature of the chamber that we are considering here. Let's suppose this is the chamber, and it contains the moist air. So because the moist air contains the water vapor and the dry air, and both the things are occupying the full chamber, that is the volume V, that is the total volume, and PV is the partial pressure of the moist air, that is the water vapor, and RV is the universal gas constant for the water vapor, and T is the temperature of this chamber. Okay, and in the denominator we can write it as PA into V divided by RA into T. And we also know the another formula, that is the this RV equal to R divided by the molecular weight of the water vapor, and Ra is equal to R divided by the molecular weight of the dry air. And we know that the R is the universal gas constant, that is equal to 8.314 divided by the molecular weight of the water vapor, that is the water itself, so its molecular weight is 18. And the universal gas constant in the case of this Ra, so Ra is equal to R divided by the molecular weight of air, that is the dry air, and it can be written as 8.314 divided by 28.97, that is the molecular weight of dry air. Okay, and the other formula that I am saying here is, that is the let's suppose the PT is the total pressure, which is equal to the partial pressure of the water vapor and the partial pressure of the dry air. So it is PV plus PA. Okay, so let's put all of these formulas into this formula. So it can be written as, so V से V cancel हो गया and T से T cancel हो गया. So V and T are cancelled out, and then we can write it as PV divided by PA into here RA divided by RV, और PV divided by PA को हम क्या लिख सकते हैं, PT minus PV. From here you can write it as PA is equal to PT minus PV, and RA divided by RV. So RA divided by RV is equal to R divided by the molecular weight of A into R molecular weight of water vapor, that is the mv divided by ma. So mv is the molecular weight, that is the 18 divided by 28.97. so it will come out to be 0.622. okay, so हम यहाँ पर लिख सकते हैं 0.622 in the brackets. So the final formula that we get here is equal to the specific humidity is 0.622 into PV divided by PT minus PV. So this is the formula and आपको ये formula याद रखना है अच्छे से. Okay, and now let's look at the other thing, that is the relative humidity. Relative humidity को भी हम समझ लेते हैं, उसके फॉर्मूले को हम देख लेते हैं. So this is for the relative humidity. So it is represented with this symbol phi, and it is equal to, so it is the mass of water vapor divided by the maximum water holding capacity of the air. So it is the mass of the water vapor mv divided by mass of water vapor when it is saturated. और जब maximum water holding capacity होती है तो ये तभी होती है जब saturated air हो. So mv divided by the mvs. So mv is the mass of water vapor in air, and the mvs mass of water vapor in saturated air. और एक चीज़ तो आपको समझ में आ ही गई होगी कि mvs is always greater than the mv. It means this phi is always less than 1 or can be equal to 1. okay, so if it is phi is equal to 1 in the case of saturated air. Although these things are not asked in an exam, but it is the kind of generalization. आप इस चीज़ को एक बार देखते ही समझ सकते थे कि ये चीज़ें ऐसे इस तरीके से काम करती हैं. एंड देन so mv divided by mvs. So again, if we write it in this form, pv into v divided by rvt divided by this pv into v divided by rv into t, और यहाँ पर pvs आ जाएगा. ठीक है, बस यही अंतर था. rv दोनों जगह सेम ही रहेगा बिकॉज rv इज इक्वल टू r डिवाइडेड बाय द मोलिकुलर वेट ऑफ द वाटर वेपर. ठीक है, तो ये चीज़ें सेम रहेंगी. सो फाइनली if we cancel out this v, r and t in the numerator and the denominator, we will left out with this pv divided by pvs. okay, so it is easy. Then we can write it as, so if we convert this pv pt minus pa, and finally if we include this formula or the specific humidity in the relative humidity, then we can write it as 1.6 into w into pa divided by pvs. So if we substitute this thing, so it is easy to derive this thing. So you need not to be panicked or worry about this thing कि ये मैंने कैसे derive किया है. If you just take this formula into the relative humidity formula, you can very well derive this formula. okay, so finally what we are getting here is that this phi is equal to this pv divided by pvs equal to 1.6 into w into pa divided by pvs. okay, so just remember this formula. ठीक है, एक तो हमने ये फॉर्मूला समझा था, एक हमने ये फॉर्मूला समझ लिया. नाउ वी विल बी टॉकिंग अबाउट आवर थर्ड फॉर्मूला, दैट इज द स्पेसिफिक वॉल्यूम. स्पेसिफिक वॉल्यूम का फॉर्मूला एक बार हम देख लेते हैं. So let's understand the next formula, that is the specific volume formula. So it is written as, for the specific volume of the humid air or the moist air, it is represented in this form, and the unit is meter cube per kg of dry air. Okay, so it is equal to 0.082 into T dry plus 22.4 bracket close into 1 divided by 28.97 plus W divided by 18. So just remember this formula. I know that this formula might be very difficult for you to remember, but please try to remember this formula, because the direct question has come in the previous year in 2019, जहाँ पर ये 2 मार्क्स का क्वेश्चन के ऊपर ये सिर्फ आपको अगर फॉर्मूला याद था, so you can very well attempt the question, और you could very well attempt the question. So एक चीज़ आप यहाँ पर ये कर सकते हैं कि this 28.97 can be replaced with 29. Okay, so the formula can be written in this form: 0.082 into T dry plus 22.4 into 1 divided by 29 plus W by 18. इसमें कोई मिस्टेक नहीं होगी अगर आप ऐसा कर भी दें. इफ़ यू रिप्लेस दिस 28.97 with 29, so I know that you can understand that this thing is the molecular weight of the dry air and 18 is the molecular weight of the water. Okay, because the gate question or the gate authority gives you a range in which your answer should lie. ठीक है, मैं अभी आपको एक न्यूमेरिकल दूंगा जिससे आपको समझ में आएगा कि आपको एक रेंज दी जाती है जिसके बीच में आपका आंसर मैच करना चाहिए. ओके, सो लेट्स सी. So this question came in GATE 2018 for 1 mark. So this question came in GATE 2018 for 1 mark. Now the question is that ambient air at 30 degrees Celsius dry bulb temperature and 80% relative humidity was heated to a dry bulb temperature of 80 degrees Celsius. It means the temperature initially was 30 degrees Celsius and later it became 80 degrees Celsius in a heat exchanger by indirect heating. Okay, the amount of moisture gained during the process would be. Now please understand that how this heat exchanger works. हीट एक्सचेंजर किस तरीके से काम करता है, अगर आप ये समझ लेते हो तब आपके लिए ये क्वेश्चन बिना पेन उठाए भी आप कर सकते थे. So this is how the heat exchanger system works. So one fluid through this pipe and the other fluid through this pipe, and there is indirect heat exchange. It means there is no way of contact for the both the fluids to come in contact with each other, right? तो यहाँ पर इन दोनों फ्लूइड्स के पास कोई भी ऐसी जगह नहीं होती जहाँ पर ये एक दूसरे के साथ कॉन्टैक्ट में आ सके. इट मीन्स बोथ द थिंग्स आर आइसोलेटेड इन टर्म्स ऑफ मास एक्सचेंज. तो यहाँ पर मास एक्सचेंज नहीं होता, जिस वजह से इसमें चाहे कंडीशंस कुछ भी हो, यहाँ पर 30 डिग्री की बजाय चाहे 40 होता या 50 होता या 60 कुछ भी हो, it does not vary, and even relative humidity भी कुछ भी होती, it really does not matter. So the answer would be 0. आंसर यहाँ पर 0 आएगा because the amount of moisture gained during the process would be 0 because there is indirect contact. इट मीन्स जो फ्लूइड इसमें फ्लो हो रहा है वो किसी और चीज़ के कांटेक्ट में नहीं आ रहा है, तो इसका जो शुरुआती मॉइस्चर रहेगा वही मॉइस्चर आखिर तक बना रहेगा, राइट? सो आप इस चीज़ को अच्छे से समझ सकते थे. बट एक चीज़ और यहाँ पर देखिए, अगर क्वेश्चन आपसे ये पूछ लेता कि यहाँ पर शुरुआत में 30 डिग्री ड्राई बल्ब टेम्परेचर था और रिलेटिव ह्यूमिडिटी 80% थी, देन the temperature increased to 80 degrees Celsius, then how the relative humidity will be changed? or how the relative humidity will change. So as you can see here that we have looked that the dry bulb temperature is inversely proportional to the relative humidity, or the relative humidity is inversely proportional to the dry bulb temperature, and the dry bulb temperature is increased from 30 degree to 80 degree, and then the relative humidity will come down. यानी 30 डिग्री से अगर 80 डिग्री तक यहाँ पर ड्राई बल्ब टेम्परेचर पहुँच गया है तो जो रिलेटिव ह्यूमिडिटी है वो कम हो जाएगी समय के साथ। ठीक है, तो ये आप चीज़ यहाँ पर समझ सकते थे। सो आई होप दैट नेक्स्ट टाइम अ क्वेश्चन कैन कम ऑन दिस कंसेप्ट दैट आई हैव जस्ट टोल्ड यू, जहाँ पर आपको ए बी सी करके 4 ऑप्शन दे देगा examiner, and he will ask you how the relative humidity will change. So this kind of question can come in the future gate exam. So but for now, if you look at this question again, then the answer would be 0. Okay, now let's look at another question. So this is the next question. So this question came in gate 2019 for 2 marks. Okay, the question is that the room air is at 40 degrees Celsius with 60% relative humidity. Okay, so these are the two things that are given here, and the saturated vapor pressure of water at 40 degrees Celsius is this much. Okay, yani itna hai, and the volume of the humid air is asked. So it is the specific volume of the humid air or the moist air that is asked here. So specific volume is asked. So we have just looked at the specific volume formula. स्पेसिफिक वॉल्यूम फार्मूला अभी हमने थोड़ी देर पहले देखा भी था. सो इट इज़ इक्वल टू 0.082 इंटू ड्राई बल्ब टेम्परेचर प्लस 22.4 इंटू 1 डिवाइडेड बाय 29 प्लस स्पेसिफिक ह्यूमिडिटी डिवाइडेड बाय 18. Okay, and this dry bulb temperature is in degrees Celsius. You need not to convert it into degree Kelvin. Okay, so the dry bulb temperature here is 40 degrees Celsius, and the relative humidity, that is phi, is equal to 60%. Okay, and we have to calculate this W. So how to calculate this W if we have the relative humidity? So हमने यहाँ पर ऊपर एक चीज़ देखी थी, एक फॉर्मूला देखा था, एक बार मैं आपको दिखा भी देता हूँ. आप इस फॉर्मूले को देखिए यहाँ पर, कि जहाँ पर W और इस रिलेटिव ह्यूमिडिटी के बीच में यहाँ पर रिलेशन हमने डेराइव किया था, एंड वेयर द पी ए इज़ the atmospheric pressure and PVS is the vapor pressure of the air when it is saturated. Okay, so let's write this formula again. So this phi is equal to 1.6 into W into PA divided by PVS. Okay, and we know this PA, which is equal to 101.325 kilopascal, that is the atmospheric pressure. Please remember this thing. Please do remember this thing. And the PVS that is given here is saturated vapor pressure of water at 40 degrees Celsius. So it is the same temperature. So यहाँ पर ये जो प्रेशर है ये है saturated vapor pressure. So it is equal to 7.375 kilopascal. Okay, so we know the value of phi, that is 60%, and we know the value of PA and PVS, so we can calculate the value of W, right? So W is equal to phi divided by 1.6 into PVS divided by PA. Okay, So its value will come out to be इसकी जो वैल्यू आती है वो आती है 0.0273. So the value of W is equal to this, and we will substitute this value into the given formula. So the specific volume will be equal to 0.082 into, so 40 is the dry bulb temperature and 22.4 into 1 divided by 29 plus W, that is the 0.0273 divided by 18. So the final answer that we are getting here is 0.924. So this is our answer. And in the gate key, the answer is should lie in the range of 0.924 to 0.93. So your answer should lie in this particular range. ठीक है, इस रेंज में आपका आंसर लाई होना चाहिए था. तो ये हमारा फाइनली आंसर है. और ये आप अच्छे से इस फॉर्मूले को याद रख लेना, बिकॉज क्वेश्चन क्योंकि एक बार आ चुका है तो प्रोबेबली क्वेश्चन नेक्स्ट टाइम पॉसिबली ना आए, बट क्योंकि ये जो क्वेश्चन आया था 2019 में आया था एंड दिस टाइम दिस इज़ 2023, तो करीब 4 साल हो जाएंगे इसको. तो 4 साल में पॉसिबिलिटी है कि ये कंसेप्ट दोबारा रिपीट हो जाए, राइट. सो नाउ लेट्स लुक एट द अनदर क्वेश्चन. So this is our next question. So this question came in GATE 2012. GATE 2012 में ये आया था और टोटल 4 मार्क्स का ये क्वेश्चन था. 2+2 दो क्वेश्चंस हैं यहाँ पर, तो दो नंबर के आए थे ये क्वेश्चन. अभी इस चीज़ को समझिए कि यहाँ पर एक क्वेश्चन कहना क्या चाह रहा है. सो द क्वेश्चन इज़ एयर एट 1 एटमॉस्फेरिक प्रेशर. ये मैंने चीज़ आपको ऑलरेडी बता दी है, और आप इस चीज़ को हमेशा से याद रखिए कि जो चीज़ें एक बार पूछी जा चुकी हैं पेपर में, तो ये चीज़ें दोबारा से पूछी जाती हैं. ठीक है, इसी चीज़ के ऊपर 2019 में क्वेश्चन आया था. अगर आपको एक 1 एटमॉस्फेरिक प्रेशर का मतलब पता था इन टर्म्स ऑफ किलो पास्कल, तो आप उस क्वेश्चन को अच्छे से अटैम्प्ट कर सकते थे, जो अभी हमने लास्ट क्वेश्चन अटैम्प्ट किया. तो आप प्लीज़ अच्छे से इन यूनिट्स को याद रख लेना, क्योंकि ये अगेन एंड अगेन दीज थिंग्स आर आस्क्ड in one or the another way. And the question is, so air at 1 atmospheric pressure and 30 degrees Celsius with absolute humidity. So absolute humidity means the specific humidity. इस चीज़ को भी याद रखिए. It is the specific humidity of dry air is flowing in a drying chamber. यानी एयर जो है इस प्रेशर पर और इस टेम्परेचर पर जिसकी ह्यूमिडिटी इतनी है वो फ्लो हो रही है किसी एक ड्राई चैम्बर में. द सैचुरेटेड वेपर प्रेशर ऑफ वाटर इन किलो पास्कल, यानी इतना दिया गया है यहाँ पर, एंड इज रिलेटेड टू टेम्परेचर इज गिवन बिलो. तो ये जो यहाँ पर ये पी नॉट डब्ल्यू, यानी यहाँ पर ये कुछ इस तरीके से लिखी हुई है, ये पी नॉट डब्ल्यू. So this is the saturated vapor pressure and this is the temperature. So this is the relation that is given here. तो इस रिलेशन को हमने फॉलो करना है. So we have to follow this particular relation to solve the numericals. So the heat capacities of the dry air and that of the water vapor are these. Latent heat of vaporization is this. तो ये चीज़ें हम बाद में यूज़ करेंगे when we try to solve this enthalpy वाला question. So we will also look at the derivation of this formula, but first we will look to solve this particular question. तो इस क्वेश्चन को सॉल्व करने के लिए क्वेश्चन क्या है कि द रिलेटिव ह्यूमिडिटी इज, रिलेटिव ह्यूमिडिटी ये पूछ रहा है. सो द फॉर्मूला फॉर द रिलेटिव ह्यूमिडिटी दैट वी नो इज इक्वल टू पी वी डिवाइडेड बाय पी वी एस, एंड वी नो दैट this PVS can be solved from this formula because it is the saturated vapor pressure and the T, that is the temperature. So this is the relation between the saturated vapor pressure and the temperature T. So we can calculate this PVS easily, but how to determine this value PV? तो इस PV को कैसे डिटरमाइन किया जाए. बट वी हैव टू ऑल्सो लुक एट अनदर थिंग्स, दैट इज द this absolute humidity is also given. So we know that this absolute humidity or the specific humidity is equal to 0.622 into PV divided by PT minus PV. Okay, so that's simple for us to understand. So we know the value of W that is given here, and we have to calculate this value PV to determine this value relative humidity, and we know the value of PT, that is this 1 atmospheric pressure, that is the total pressure, right? So if we try to solve this value PV when the value of W is equal to 0.0218 is given and the value of PT is equal to 101.325 kilopascal is given, so we can calculate the value of PV, that is equal to 3.43 kilopascal. Okay, and be careful that this saturated vapor pressure is given in kilopascal, so we need not to worry about the change in the or the for the change in this these units. So we can calculate this value PVS from the given formula that the question has given us. So the PVS, so ln of PVS is equal to this 18.6556 minus 5217.635 divided by T. So T यहाँ पर क्या है अभी? T is the 30 degrees Celsius, so it is given here. T is in degree Celsius जैसे कि यहाँ पर बताया भी गया है. So 30 plus 273. So finally that we get the value of PVS equal to it is 4.17 kilopascal. Okay, so we can calculate this value phi. So it is 3.43 divided by 4.17 kilopascal. So it comes out to be 82.08. 82.08 is the answer, but as this answer is not matching with any of the options, so by this logic, which is the approximate nearest value to this answer is D. So I am putting or checking this value further, यानी मैं इस ऑप्शन को करेक्ट मानता हूँ क्योंकि मेरा जो आंसर आ रहा है उसके नियरेस्ट वैल्यू तो यहाँ पर कोई यही है और एग्जैक्ट वैल्यू को यहाँ पर दिख नहीं रही थी. एंड आई बिलीव कि द वेरिएशंस इन द आंसर इट माइट बी बिकॉज ऑफ दिस एलन वैल्यू, कि यहाँ पर ये जो इतनी लेंथी वैल्यूज़ यहाँ पर दी गई हैं इसकी वजह से यहाँ पर डिफरेंसेस आ रहे हैं. सो इसमें कोई घबराने वाली बात नहीं है. द आंसर इज़ करेक्ट. जो डी ऑप्शन था वो एकदम सही है, तो इसमें आपको बिल्कुल भी कुछ भी घबराने की वाली चीज़ नहीं थी. ठीक है, तो आप इसी ऑप्शन को सही मान सकते हैं. नाउ लेट्स लुक एट द एंथैल्पी ऑफ द मोइस्ट एयर. सो दिस इज द नेक्स्ट क्वेश्चन हेयर. सो एज वी हैव नॉट लुक्ड एट द फॉर्मूला फॉर दिस, so now let's look at the formula for the enthalpy of the moist air, that is the humid heat of the moist air. Or the enthalpy of, so this is our fourth formula, that is the enthalpy, ENTHAL, enthalpy of a moist air, that is equal to H equal to the enthalpy of the dry air plus enthalpy of the moist air, that is the or the water vapor. So H is equal to H of air plus W into H of vapor. So it is finally equal to H equal to 1.005 into dry bulb temperature plus W into 2500 minus 1, or this is the plus here, 1.88 into T of dry bulb temperature. So this is in terms of kilojoule per kilogram dry air. तो इस फॉर्मूले को याद रखना है. सो प्लीज डू रिमेंबर दिस फॉर्मूला. सो द एंथैल्पी ऑफ द moist air is equal to 1.005 into dry bulb temperature plus the specific humidity into 2500 plus 1.88 into dry bulb temperature. So it comes out as the enthalpy of the moist air. Okay. So here, as we know that this dry bulb temperature, that is the dry bulb temperature is the 30 degrees Celsius. So we need not to convert it in the Kelvin, and the W is equal to the specific humidity that is also given here. यहाँ पर देख लेते हैं. So it is 0.0218. So it is equal to 0.0218. So if we write all the things in the given formula, so the H is equal to 1.005 into 30 plus 0.0218 into 2500 plus 1.88 into 30. So finally the answer we get is 85.87 kilojoule per kilogram. Okay, so the option A is the correct answer. So I hope कि यहाँ पर आपको चीज़ें समझ में आ रही हैं कि चीज़ें किस तरीके से काम कर रही हैं. मैं फिर से आपको एक बार बता दूं कि यहाँ पे हमने आज क्या क्या किया है. सो आई विल अगेन टेल यू दैट व्हाट वी हैव लर्नड सो फार in this video. So the first we looked at the Gibbs phase rule, but this formula is not required to be understood from the gate point of view, but as an engineer you have to look at this thing that how or what number of variables you require to understand any thermodynamic system. So the answer came out to be equal to 3, but as the atmospheric pressure is the pressure at which all these things happens, so the only two parameters that we are left with, the first is the temperature and second is the moisture. And after that we looked at some of the formula. The first we looked about was the specific humidity, and the second was the relative humidity, then third was the specific volume, then after that we looked at the enthalpy of the moist air. Okay. So the specific humidity that you can see on the screen as the mass of water vapor divided by mass of dry air. So if this is considered as a chamber which contains both the dry air and the water vapor, and let's suppose the water vapor are 100 gram and the dry air as 900 grams, so it is equal to 1 by 9 as the specific humidity. And similarly we calculated the relative humidity, which is equal to moisture in air divided by the water holding capacity of the air. It means when the air is saturated, so it is the maximum water that the air can hold. So let's suppose it is 200, so 100 by 200 comes out to be 50% as the relative humidity. So after that we derive formula for the specific humidity and the relative humidity. So for the specific humidity, mv by ma, that is the mass of water vapor divided by mass of air, and using the ideal gas formula for the air, we substituted this formula into the given formula. So and with this the total pressure is equal to PV plus PA, and the universal gas constant we talked about. So all of these things when replaced or when substituted in the given formula, so we finally came up with our formula for the specific humidity. And then we looked at the formula for the relative humidity. So the formula is that mv divided by mvs. So I hope this was easy for you to understand that the RV in both the cases are same. So the final formula that we derived here is this PV by PVS. So 1.6 into W into PA divided by PVS. And the next formula that we looked about was the specific volume of humid air. So it is the meter cube per kilogram of dry air. So this is the formula that you have to mug up. I'm literally saying this word mug up because it is very much difficult for you to logically understand all the things and finally convert these things into the paper to get the marks. तो ये मैं ये बता रहा हूँ कि इन चीज़ों को पहले याद करना, समझना और फिर उसके बाद पेपर में उसको कन्वर्ट कर पाना मुश्किल होता है। तो इसीलिए आप इन फॉर्मूलाज़ को अच्छे से याद कर लो, रट लो बल्कि, ताकि आपको उस समय कोई भी दिक्कत ना हो, ठीक है। और मैंने यहाँ पर ये बताया कि जो स्पेसिफिक वॉल्यूम ऑफ ह्यूमिड एयर है, सो इट इज़ इक्वल टू 0.082 इंटू ड्राई बल्ब टेम्परेचर प्लस 22.4 इंटू 1/29 प्लस W/18। तो ये टर्म आपको इजीली याद हो जाएगी। एंड प्लीज़ डू रिमेंबर दिस टर्म ऑल्सो बिकॉज द वेरी नैरो रेंज फॉर द आंसर इज़ गिवन बाय द गेट अथॉरिटी। तो इसमें आप कहीं पे भी कोई मिस्टेक मत करना, प्लीज़ डू नॉट डू एनी मिस्टेक in remembering these numbers. So it is 0.082 and this is the 22.4, this is 29 and 18. Okay, so next we solved a numerical which was on the indirect heating. So as we know the concept of this indirect heating, so there is no exchange of the mass, so there is no moisture gain, so that's why the answer was 0. And along with that I also taught you that this is the dry bulb temperature which is inversely proportional to the relative humidity. Rather, it is very incorrect to say the dry bulb is inversely proportional to the relative humidity. Rather, it would be right to say that the relative humidity is inversely proportional to the dry bulb temperature, right? And then we saw that कि अगर क्वेश्चन कुछ ऐसा आता है जहाँ पर ये पूछा जाता है कि रिलेटिव ह्यूमिडिटी पर क्या फ़र्क पड़ेगा, सो वी कैन ऑल्सो कंक्लूड दैट as the dry bulb temperature is increased here in this question, so the relative humidity will come down. And if the examiner asks you to calculate the value for the relative humidity, then we can calculate it as well. And in the next video we will look at how to determine the value if we look at the graph or the psychometric chart that is given. तो साइकोमेट्रिक चार्ट को देख के हम कैसे आइडिया लगा सकते हैं कि किसी भी पैरामीटर की वैल्यू क्या होगी. एंड नेक्स्ट वी लुक्ड एट द क्वेश्चन फॉर द स्पेसिफिक वॉल्यूम. सो इस क्वेश्चन को हमने सॉल्व किया एंड इट वाज इजी. So the question was the room air is at 40 degrees Celsius with the relative humidity given and the saturated vapor pressure is also given. तो क्योंकि सैचुरेटेड वेपर प्रेशर हमें दिया गया था तो यहाँ से हम फाई कैलकुलेट कर सकते थे, द स्पेसिफिक ह्यूमिडिटी कैलकुलेट कर सकते थे. एंड वंस वी कैलकुलेटेड द स्पेसिफिक ह्यूमिडिटी वी फाइनली सब्स्टिट्यूटेड दिस वैल्यू इनटू द गिवन फॉर्मूला फॉर द स्पेसिफिक वॉल्यूम. And after that we solved this numerical which came in GATE 2012, that is the around 10 years back. So this question came in 2012 and for the 4 marks. So the first question was asking about the relative humidity and the second was asking about the enthalpy of the moist air. So हमने यहाँ पर इन चीज़ों को समझ लिया and along with that we also looked at the fourth formula that is for the enthalpy of the moist air. So it is equal to 1.005 into the dry bulb temperature plus W into 2500 plus 1.88 into this dry bulb temperature. So here the dry bulb temperature is taken in the form of in the degree Celsius and the specific humidity is also given. ठीक है, you need not to convert it into the degree Kelvin. So this is all about the formulas that we have to look upon. So that's all for today and आज के लिए सिर्फ इतना ही एक बार हम करते हैं और यही क्वेश्चंस क्योंकि प्रीवियस ईयर्स में आए थे और ज़रूरी लगेगा अगर मुझे तो मैं नेक्स्ट वीडियो में आपको कुछ एक क्वेश्चंस और करवा दूंगा. सो आई विल कम अप विद सम अदर क्वेश्चंस इन द नेक्स्ट वीडियो which are based on the similar questions that have come in the previous year for this psychometry along with the some other concepts on the psychometric chart. ठीक है, तो आज के लिए सिर्फ इतना ही रखते हैं, क्योंकि मैंने कहा था कि वीडियोस को एकदम छोटा रखेंगे हम अभी, क्योंकि ये न्यूमेरिकल्स आपको थोड़ा बोदर कर सकते हैं, थोड़ा आपको दुख दे सकते हैं, क्योंकि ये फॉर्मूला याद करना मुझे पता है कि इजी नहीं है और लास्ट मोमेंट तक याद रखना भी इजी नहीं है। तो आई विल रिकमेंड यू, प्लीज़ डू रिमेंबर दीज फॉर्मूला एंड ट्राई टू री लुक एट दीज फॉर्मूलाज अगेन एंड अगेन। दोबारा दोबारा इन क्वेश्चंस को देखते रहिए, इन न्यूमेरिकल्स, इन फॉर्मूलाज को देखते रहिए, ताकि ये आपके जहन में बैठ जाएं। सो दैट्स ऑल फॉर टुडे। सो अभी के लिए सिर्फ इतना ही रखते हैं, अभी हम नेक्स्ट वीडियो में मिलेंगे और कुछ नई जानकारियों के साथ। सो दैट विल बी अवर फाइनल वीडियो, एंड ऑल्सो आई विल ट्राई टू मेक वन वीडियो फॉर द ऑन द साइज रिडक्शन के ऊपर अभी थर्ड पार्ट लाना मेरा बाकी था, और वो मैं लाऊंगा ज़रूर आपके एग्ज़ाम से पहले, और वो एकदम थियोरेटिकल रहेगा। सो let's meet in the another video, that is the part 3 of this psychometry, and after that we will be meeting again with the for the third part of the size reduction. So okay, and bye bye for today.